Hello everyone, welcome to video 9 of chapter 5. In this video we will cover chapter 5.5. We'll discuss the change in the constant term, and that is the term we called B. How would that affect the solution to the LP problem? Okay, so we begin with making an observation. We see that first, if we change this B, this actually does not affect the pivot process on the left. We can go through the same pivot process and we can put the left-hand side in the canonical form. Okay, so now recall the expression of Z min is equal to Z naught minus CB B inverse times B. So I highlighted B in red, so you know that's the thing we're going to change. So even though the pivot process is the same, and so B inverse and CB are the same, we see that the change in the B would change the minimum value. And there is another thing we need to be careful. That is, after the pivoting, we still need to make sure that the solution is feasible. That is, the B star should remain non-negative. Okay, so with those 2 points, keep them in mind. Let's take a look at an example. Let's see, we have this problem. It's a max form, an objective function, and 2 constraints. And then I highlight this 50 in red because that is the one we're going to change. Let's see, if we want to change 50 to 53 for this B2, what happens to the solution? Okay, so let's first get the B matrix. This we know how to do. And then we also compute the inverse of the B. And then using that, I can compute the B stars, right? B star is this B inverse times the B on the right-hand side. So now the right-hand side is changed into 28 and 53. Okay, that's what's required. Okay, if you carry this out, and you have 3 and 16. So it's bigger than 0, so that's okay. So this means I can keep the basic variables, which is x4 and x2. They can still serve as basic variables. And then what will be the new optimal value? Well, the new optimal value would be now the coefficient 15 and 4 for x4 and x2, and the value for x4 and x2, that's 3 and 16. Let's put it in, and then you work out and you get 109. Okay, now let's have a more general discussion. Let's say B2 now is changed to 50 plus lambda, and we let lambda denote the change. Okay, and then we can repeat the computation with this plugged in. So what will be the B star? Well, that will be B inverse times little b. B inverse times the little b will be 28, and down here will be 50 plus lambda. Okay, so, and then we can again break this vector into 2, into this vector plus this vector, and then we multiply the B inverse in front. And then you know this one will be the previous value in the tableau, and then this second part, let's write out B inverse times 0 lambda, and then we're going to work out. Okay, so we know on the top will be 2 times 0, negative lambda. So it's negative lambda. The first element, we combine it with 6, we get 6 minus lambda. And the second one is 4 lambda, so I have 4 plus 4 lambda. And both elements shall be bigger than equal to 0. So we get 2 constraints. Okay, so let's write them out. So I need to have 6 minus lambda bigger than 0 and 4 plus 4 lambda bigger than 0. And solving each inequality, the first one gives me lambda less than 6 and the second one gives me lambda bigger than negative 1. Okay, so that made me conclude I need to have lambda between negative 1 and 6 such that the B star will be non-negative. So remember that the B star need to be non-negative such that the solution, the basic solution, would remain feasible. Okay, and if lambda is in this range and the B star is bigger than 0, solution is feasible, and then we can compute the max, Z max, which is 15, 4 dot. What are the two elements? It's these two, right? B star. So 6 minus lambda, 4 plus 4 lambda, and you work out this dot product, and then you distribute and collect the constant term, which is 106, and then you collect the lambda term, negative 15, and 16 give you lambda. So that's the Z max by adding this change lambda here into B2. Okay, so here's the final conclusion. We conclude that if lambda is between negative 1 and 6, then the Z max is this value. So this basically says that if you make 1 unit of change in lambda, that would cause 1 unit of change in the Z max. And the coefficient here, kind of the rate in Z max respond to the changes in lambda, is 1. Okay, some observations before we end. First one, so recall that the coefficient of lambda in the objective function is 1, positive 1. So where does that come from? Well, recall the concept we called and the shadow price. And so we notice that this is also the marginal value for the second constraint. So if we look at the tableau here, so we see that x5, x6 were added as slack variable. x6 is for the second constraint, and then it has the marginal value of 1. Okay, and then we also know that this is the solution, the second element in the solution y star of the dual problem. And second observation, so as long as x4, x2, these two here remain basic variable, then the final tableau remains. And then the optimal solution for the dual problem remains these here. That's where you find the solution for your dual. We talked about that. Okay, when that is the case, then I can write the Z max would be also the solution of the optimal problem. So I can take y star, which is 2, 1, dot product, the coefficient for that objective function, which is 28, and then 50 plus lambda. And if we work out this, we find out that the constant term is 106, and then plus the lambda. So note that this is the same as the one we obtained by dealing with the original problem, not the dual. So the dual gives us the same thing. Okay, so final remark, and if the B stars shall have negative value, that is, if the lambda is outside the range that we found earlier, what happens? So let's see. If I take lambda equals 7, then you can go through the computation and you find out that B star now is negative 1 and 32. So this first term becomes negative. That means the solution is no longer feasible, and then we would need a new procedure. Okay, so this will be the topic of the next chapter. So stay in tune, and I hope you enjoy this one. See you next time.